Good morning, all. My name is Manohar Reddy, Assistant Professor, Department of Cybersecurity, IARE College, Institute of Aeronautical Engineering College. So, I am going to teach the subject is Mathematical Foundations for Cybersecurity. So, Mathematical Foundations for Cybersecurity. So, what are the foundations we need to know about cybersecurity? So, in this entire concepts, we are going to learn from this subject. So in the mathematical foundations for cybersecurity, so first of all we are going to know about number theory. So first of all we are going to number theory. So what is meant by number theory actually? So the name itself, number theory, the name itself number. So we are going to study about all the different types of numbers. So a number is nothing but an integer. You can say that an integer, which is a digit, also you can call it as. So number theory is the complete study of all the set of positive integers, set of all the positive integers. So you can take any of the numbers. So you are going to study about all those numbers. So like examples 1, 2, 3, 4, 5, 6, 7. These are all natural numbers. You can say that n equals to 1, 2, 3, 4, 5, 6, 7. So not only about these natural numbers, you are going to learn about natural numbers, rational numbers, relational numbers, any of the numbers. So you are going to learn about all the numbers. So in this unit, so number theory, so study of all the numbers, different types of numbers, so which is also called as natural numbers. And here you can see all the different types of numbers. So odd numbers, so 1, 3, 5, 7, 9, 11 examples. So these are all, you can say that odd numbers which are not divisible by 2. It's not divisible by 2. So 1 is not divisible by 2. So you can say that these are all the numbers are odd numbers. And even numbers, the numbers which are divisible by 2 is called as all even numbers. So you can see both odd numbers and even numbers. So you can see difference between odd numbers also even numbers. And next is square numbers. So square numbers, the square of that number, square of any number. So you can take 1. So the square of this number is 1 into 1. You can say that. So 1 into 1 is also called as 1. And similarly, you can take any of the number 2. So the 2 number is a square of this 2. You can say that 2 into 2. That is 4. So that is 1, 4, 9, 16, 25, 36. So these are all the square of the number which you are enter. So you can enter either odd numbers, you can enter either even numbers, whatever it may be. There is no limitations to find particular square numbers. And next, cube of the numbers. So cube of the numbers. So you can take any of the number and you can multiply 3 times. So 1 into 1 into 1. So that equals to 1. So that is nothing but 1 cube. You can say that. So 1 cube is nothing but 1. So the cube of 1 is 1. And similarly, you can take 2. So for the 2 number, you can see 2 cube. So that is nothing but 2 into 2 into 2. So you can write 8. Right? 2 into 2 into 2, 8. So this, whatever the numbers you are going to multiply 3 times, that is nothing but cube numbers. You can say that. And whatever the numbers you are multiply for 2 times, the numbers are square numbers. Right? And then next, prime numbers. The prime numbers are nothing but the numbers which are greater than 1. Definitely you can say that which is number greater than 1. The greater than 1, and it should be not an even numbers. It should be not an even numbers. So not an even numbers. It should not even numbers. Right? So the number which is greater than 1, and it should not be even, as well as you can say that the number which is divisible by itself only. The number which is divisible by itself only. The number which is divisible by itself. So suppose you can take 2. So this only the even number, and about from this remaining all are the not even numbers. So you can take this 2. It is an even number, as well as you can say that it is a prime number, because a prime number is greater than 1. And also it should be divisible with this number, divisible with that number only, that p number only. So you can take p as a 2. So this is a prime because it is greater than 1, as well as you can say that it is divisible by only 2 number. So those all are the prime numbers, and these are all perfect numbers. So perfect numbers, so the sum of all the numbers, sum of all the numbers. So here 6 is a perfect number because you can see all the divisors of the 6 number. The divisors of the 6 number is, so you can take 6 is a divisor number, 6 is a number. The divisors to this 6 number is 1, 2, 3. So that means you can divide 6 by 1 also, you can divide 6 by 2 also, you can divide 6 by 3 also. So these all are the divisors of this number, and you can add these numbers, you can add this number, you can add this number, then you will get the result this one. So sum of this all the divisors, sum of all the divisors is nothing but perfect number, you can say that. So perfect number is nothing but the sum of all the divisors, sum of all the divisors of this number equals to the same number, that is nothing but perfect number. So again you will take example 28. So in the 28, the divisors of this 28, you can say that 1, 2, 4, 7, 14. 1, 2, 4, 7, 14. So these are all the divisors to this number 28. So 1 is divisible to the 28, and 2 is also divisible to the 28, and 4 also divisible to the 28, and 7 also divisible to the 28, and 14 also divisible to the 28. So you can see all these, sum of all these numbers, sum of all these numbers 1, 2, 4, 7 plus 14. So sum of all these numbers is equals to the same number 28. So then you can say that 28 is also a perfect number. And 496, 496 also 1 plus 2 plus 4 plus 8. So like the way you can see all the different types of numbers, not only these numbers, you can see modular numbers also, modular numbers, Mersenne numbers, format numbers. So you can see different types of numbers. In the coming sections we are going to discuss about all of them. Okay, so these are all the basic what is the different types of numbers and why we are going to know about this all the numbers, right? And next, so definition of divisibility. So definition of divisibility. So generally we know that directly we are going to divide a number with another number. So you can take any of the two numbers, so m and n. So you can take the two integers m and n. So m and n are the two integers, but should not 0. M is should not 0. M should not 0, and m divides n. So suppose you can take 2 by 4. So this is m, or this is m, or this is n, or whatever it may be. You can take this as n and this as n. So if you divide this 2 by 4, then you can say that 1. So 1 by 2, or else you can say that 4. So like, so this is the way you can divide. You can divide. So that means divisibility. Divisibility means the number m divides n when m not should be 0. So then you can say that m divides a number that divides n is called as a divisor of n. A number m that divides n is called as a divisor of n. You can say that. So if suppose you can take m, as a 2 and 4 as a n. So 4 as a n, then you can say that 2 is a divisor of this 4. 2 is a divisor of this 4, because the 2 is going to be divided 4, right? So 2 by 2, 4. So that's why you can say that m is a 2 and 4 is a n. So the divisibility. So you can say that 2 is a divisor of this 4 number. So you can call it as a number m that divides n is called a divisor of n. So this contains the formula like this: n equals to mk. So n equals to mk. You can take k as integers, like k equals to 1. You can take k as any integer, k equals to 1. So there n equals to mk. So then we write m divides n. If the number divides n, then you can write like m divides n. If a number does not divides n, then you are going to write m not n. So also you can write like m not n. You can write like this also. You can write m by n if it divides. If it does not divides, then you can write m not divides n. You can write like this. So you can write this for division. If you can write this for not divide. Suppose you can take the example here. Suppose you can take an example 3 by 6. So 3 by 6 where m equals to 3 and n equals to 6. So right. So where 3 by 6. So 3 by 6 where 6 equal to what you can write? 6 equals to 3 into 2. 3 into 2. So there 2 is nothing but it is an extra integer. So that's why you can say that 3 and also 2, those two are the divisors. Those two are the divisors to this number. Those two are the divisors to this number. And 3 is a divisor. 3 is a divisor of 6. Also you can say that. So 2 comma 3 both are the divisors. So you can say that 2 comma 3 are the divisors to this 6 number. Right. So like the way you can see here 3 6. So 6 equals to 3 into 2 where k equals to 2 is a constant. But you can write both 2 and 3 are the divisors to this 6 number. Similarly, you can go for this another example 12 divides 132. So whether 12 divides 132 in the form of 12 equals 132 equals 2. So 12 into 11. 12 into 11. So 12 into 11 equals to 132. 132. So 132. So here 12 and 11 are 12 and 11 both are, you can say that divisors to this 132 number. Divisors to this 132 number. So from this point of view, you can say that so 12 is a divisor of 132 and 11 is also a divisor of 132. 11 is also a divisor of 132. So 12 comma 11 are, you can say that divisors of this 132, right? So on the other hand, suppose you can take another example 5 by 7. You can take another example 5 by 7. So 5 is not divides a. 5 is not divides 7 because 7 is odd number also. 5 is odd number also. But 5 does not divide 7. 5 does not divide 7. So that we can say that 5 does not divide 7. Right. So like the way you can say that both divisibility is the definition of divisibility. So if m and n, you can take that m and n integers, then m divides n, then you can say that m is a divisor of that n. M is a divisor of that n. So this is the way you can say that divisibility of the definition, right? And next we are going to see the next definition, greatest common divisor. So before going to greatest common divisor, before going to know about this greatest common divisor, first of all we need to know the terms like divisor, then next common divisors, then next greatest common divisor. First we need to know the divisors of the number, then next common divisors of that numbers, then next greatest common divisor of that numbers. So based on this we can say that definition, the greatest common divisor of two numbers, the greatest common divisor of any two numbers a and b is the largest number that divides both of them. So you can take a comma b as a two numbers or a comma b c three numbers. You can take any of the numbers. So you can find the divisors for, first of all you need to find the divisors of that numbers. Then you can choose the common divisors of the two numbers. Then you can select the greatest common division from those numbers. So how you are going to see? So this is the definition, greatest common divisor of two numbers a and b. So but it should not be 0. It should not be 0, both two numbers, right? So the greatest common divisor of two numbers a and b is the largest number that divides both of them. The largest number, which is the largest number from all the divisors. So that should be the greatest common divisor. And you should denote it like this way. You should denote like this way, GCD of a comma b. GCD, greatest common divisor of A comma B. Greatest common divisor of A comma B, you can say that. And if any of the GCD of A comma B, if any of the GCD of A comma B so equals to 1, then you can say that those two are relatively prime. Those two are relatively prime. So regarding prime numbers and relatively prime numbers, we are going to discuss the coming sessions. So for this and for now, we are going to know about only the divisors, common divisors, and greatest common divisors. So let us take an example. So you can see here GCD of. So what is the find the GCD of 12 comma 18. Find the GCD of 12 comma 18. So find the GCD of 12 comma 18. We need to know, first of all, we need to know the divisors of these two numbers. So first of all, we need to know what is meant by divisor actually. So if m and n, if you can take m and n values, then m divides n, then you can say that m is a divisor of n, right? So like the way, so you need to find the divisors of 12, divisors of 12 you need to know first of all. Then next divisors of 18 you need to know. So first of all, you need to follow these three steps first of all. So first of all, find the divisors of any number, then find the common divisors of two numbers, then from among these common divisors you need to get one greatest common divisor. Greatest common divisor. So how we are going to see this? So first of all, divisors of 12. So you can see here, if you write 12, so for this 12, what are the divisors? What are the divisors? So 1, obviously 1 is common for all. The next 2 is also divides 12. And next 3 is also divides 12. And next 4 is also divides 12. And next 6 is also divides 12. And 12 is also divides 12. But 12 is may not be right. 12 is may not be right. And so 12. So these are the divisors. And you can write divisors to the 18. Right? Divisors to the 18. So what are the divisors of 18? So 1 you can write, and 2 you can write, and 3 also divides 18, and 4 no, right? And 5 also no. And next you can write 6 also divisor, 6 also divisor of this 18. The next 9 is also divides 18, and then next up to 10, 11, 12, no, nothing. So all 18 also divides, but 18 is not considered. So by seeing these two divisors to the 12 and 18, you can see this 12 divisors are 1, 2, 3, 4, 5, 6, 4, 6, not 5, 1, 2, 3, 4, 6, and from 18, 1, 2, 3, 6, 19. 1, 2, 3, 6, 19. 9, not 19, 9. So from among this, so this is the divisors to 12 and divisors to 18. Right. After choosing these divisors, what we need to do? We need to side common divisors. We need to side up the common divisors. So common divisors we need to side up. So what are the common divisors? So here 1 is the common divisor for both 12 and 18. The next 2 also common divisor for both 12 and 18. And next 3 is also divisor for both. Next 4 is divisor for 12 but not for 18. So next 6 is a divisor for 12 as well as 18. So you can write 6 also. So these are the only these 1, 2, 3, 6 are the common divisors of this 12, 18. 12, 18. So 12 and 18, for these two numbers you are having these 4 are the common divisors. And you can write this only 4 numbers are the common divisors for this 12, 18. So now what you need to do, we need to find out the greatest common divisor. So as per the definition, the largest common divisor that divides both of them. The largest common divisor that divides both of them. So what is the largest common divisor? Largest number means 1, 2, 3, 6. In these 4 numbers, what is the largest number? The 6 is going to be the largest number. So So you can write 6 is the largest number that divides. 6 is the largest number that divides both that divides both 12 comma 18. 12 comma 18 you can write. So 6 is the largest number that divides both 12 comma 18. So now you can write the answer. What is, like, how you can write? So you can write like this way. GCD of 12 comma 18 equals to 6. You need to write. So you can write like this. So yeah, you'll get the question. So find the GCD of some numbers, find the GCD of 3 numbers. So then you need to follow these steps. First of all, you need to find the divisors. You need to find the divisors for A and divisors for B. Means you need to find the divisors for both numbers. Then you can find the common divisors of those two numbers. Then you can take the largest common divisor. The largest common divisor is nothing but greatest common divisor of these two numbers. Like the way you can say. Okay. So as per this example here, so divisible by 1, 2, 3, 4, 5, 6 of 1, 2, 3, 4, 6, and for this one 1, 2, 3, 6, 9. So among these 6 is the common divisor. So 6 is the greatest common divisor. So you can write GCD of GCD of 12 comma 18 equals to 6. Like the way you can write. Okay. And the least common divisor is nothing but largest one. We can say that greatest common divisor. But for the smallest one is nothing but almost all 1. Almost all is 1 for all the numbers. So least common divisor of any numbers, you can write 1, right? But 1 is common, so that you can write 1 only. 1 is the lowest common divisor. You can write. Okay. So next we can explain these examples. So GCD of 18 comma 30, GCD of 48 comma 96, and GCD of 225 comma 120. So how we are going to find the GCD of these numbers? So first of all, GCD of 18 comma 30. So GCD of 18 comma 30. So first step is what you need to do. We need to find the divisors. We need to find the divisors to 18 comma 30. So you can find the divisors to both 18 comma 30. So write like this way. For the divisors of 18, what you can write? You can write, so 1 is divides 18, and 2 is also divides 18, and next 3 is also divides 18, and 4 not, and 5 not, and next 6 also divides 18, then next 9 also divides 18, then next 12 is not divides, the next 18 also divides 8, right? But 18 is not mandatory and 18 is not compulsory to write. And next 30, so you can write 30 here. So for this 30, what are the divisors? So you can write 1 is the divisor to this 30, and next 2 is the divisor to 30. So 2 divides 30, the next 3 divides 30, and 4 does not divides, and next 5 divides 30, 5 divides 30, the next 6 also divides 30, next 7, 8, 9 is not, the next 10 also divides 30, and next 12 does not divides, and 13 also does not divides, and 14 not, and 15 also divides 30, and last 30 divides 30. And these two, whatever the numbers you are going to divide, those two are not compulsory to write, and so you can write only these two. You can write only these two. So 1, 2, 3, 6, 9, and 1, 2, 3, 5, 6, 10. 1, 2, 3, 5, 6, 10. So these two are the divisors to these two numbers 18, 30. Right. So 1, 2, 3, 6, 9 are the divisors of 18, or the divisors of 18, and 1, 2, 3, 5, 6, 10 are the divisors of this 30. Right. Now what you need to do, this is the step 1. Step 1 is what? So find the step 1 is what? Find the divisors. Find the divisors to both numbers. To both numbers. So that's what we did here, right? So the next step 2, what we need to take the common divisors. We need to take the common divisors. Step 2, take the common divisors. Take the common divisors. Common divisors. So take the common divisors. So among these two divisors, this one, what are the common divisors? So you can write 1, 2, 3, and next 6. These are the common divisors. So 1, 2, 3, 6. These are the common divisors. So next step 3, what you need to do? Find the greatest one. So among these common divisors, find the latest. Find the largest one. Find the largest one. Find the largest. That is nothing but a greatest. Largest is nothing but a greatest. So among these, the 6 is the greatest one. 6 is the greatest one. So you can write GCD of 18, 30 equals to GCD of 18, 30 equals to 6. Like the way you can write. Or else you can write like this also. 6 is the greatest common divisor of what? 18, 30. Like the way you can write. So this is the way you can find GCD of 18, 30. And next second example, you can see GCD of 48, 96. 48, 96. So here 48, 96. So first of all, what we need to do? We need to find out the divisors. We need to find out the divisors of 48. So you can write like this. So step 1 is what? We need to find the divisors. Find the divisors of 48. So 48. So what are the divisors to 48? So 1 divides 48. The next 2 divides 48. The next 3 also divides 48. The next 4 also divides 48. The next 6 also divides 48. 7 no, and 9 also no. 10 no. The next 12 also divides 48. And 24 also divides 48. And last 48. Right? So this is the way you can write 48 divisors. Then next what you need to do? 96. So for the 96 also you need to find the divisors. So for the 96, 1 also divides, the next 2 also divides, 3 also divides, the next 4 also divides, and next 5 not, and 6, yes, 6 also divides, and next 7 not divides, and 8 also divides, and next 9 is not divides, and 10 not divides, the next 12, so 12 also divides. So 12 is a divisor of this 96. So you need to know the divisors by doing like this. So 12, 48, 1, 0. So you can do like this also. You can do like this. Then you can able to find the divisors. If you want to get the divisors by easily, you can go like this method. Yes. So like this also you can do. So here 12 is the divisor for 96. The next 24, 18 is also is divisor. No, 18 not. The next 24 is also a divisor. The next 48 is also divisor. Next 96. Right. So among these all the divisors, what we need to do next? Step 2, we need to do what? We need to do take the common divisors. So what are the common divisors? 1, 2, 3, 4, 6, 12, 24. These are all the common divisors, right? So among these all the divisors, what you need to do next one? Take the greatest common one. Greatest common divisor. That is nothing but largest one. Greatest common or largest one. So what is the largest one here? So 24 is the largest one. So 24 is the largest. 24 is the largest number, largest divisor that you can say, largest divisor of this 48 comma 96. Like the way you can say that, or else you can write like this also, GCD of 48 comma 96 equals to 24. This is the way also you can write answer finally. So finding the GCD is very easy, but you need to take the common divisors. You need to take the common divisors and estimate the greatest one. What is the greatest one? You need to find. You need to choose from that common divisors. So this is what you have to do, right? And next, last example, GCD of 225. GCD of 225 comma 120. So you can see here. So first of all, what we need to do? We need to find out divisors. We need to find out divisors. So 25 to 25. So step one is what? Step one is what? 225. So find the divisors. Find the divisors. Find the divisors. So the divisors are nothing but, so 225. So 1 is divides, yes. 2 is not divides. Next 3 is also divides. Right, 3 divides. The next 4 not, and 5 divides. The next 7 not, 8 not, and 9. So 9 also divides. So because 9 1 or 9 2 is 18. The next 9 5 is 45, right? Right. So like the way you can. The next 15 also divides. 15 also divides. The next 25 also divides. So like the way you can find the divisors. 25, the next 220. And 45 is also divides. So like the way. Right. So these are the divisors. And next 120. So divisors of 120. So 1 is the divisor of 120. The next 2 is also divisor of 120. Next 3 is also divisor of 120. And 4 is also a divisor of 120. The next 5 is also divisor of 120. The next 6 is also divisor of 120. And 8 is also divisor of 120. The next 9 is not. The next 10 is also divisor of 120. And next 12 is also a divisor of 120. The next 15 also a divisor of 120. The next 18 not. The next 20. Right. So 20, 30. So 40. Like this way you can find. You can take all the divisors. You can take all the divisors. So among these all the divisors, what you need to do next one? Step 2 is take the common divisors. Take the common divisors. So take the common divisors and take. So what are the divisors? Common divisors of these numbers? Take the common divisors. So 1, yes, right, 1 and 3 and 5, and next 5, then next 15, 5, 15. So these are all the common divisors. 1, 3, 5, 15. 1, 3, 5, 15 is the common divisors from these all the numbers, right? So for that, what we need to do next step 3 is what? Find the greatest one. So among these four common divisors, we need to take one greatest common divisor. That is nothing but 15. So 15 is the greatest common divisor. 15 is the greatest common divisor. 15 is the greatest common divisor, right? So like the way you can follow these steps. Step 1, step 2, step 3. So finding the GCD, you can write like this also. GCD of 225, 120 equals to 15. GCD of 225, 120 equals to 15. Like that we can write it. Or else you can write like this also. 15 is the greatest common divisor. Greatest common divisor of 225, 120. Right? So like this way you can do the practices also. So find the GCD of any numbers. They can give any numbers. So if you want to find out, you can take complex numbers also. And for this greatest common divisors, we are going to find the greatest common divisor with the help of different techniques. Different techniques. This is the divisor method. You can say that. So divisor method. So divisor methods, we need to find out the divisors of the numbers. Then next take the common divisors. Take the common divisors. Then next find the greatest common divisor. Right, and you can practice another example like GCD of 100 comma 200. GCD of 100 comma 200. So for 100, what will get the divisors for 100? The divisors of 100 equals to. So 1, you can write 1 is divisible, 1 is divides 100. The next 2 is also divides 100. 3 not, and 4 also divides 100. 5 also divides 100. The next 10 also divides 100. The next 20 also divides 100. 25 also divides 100. Right, so these are all some divisors of these numbers. And for 50 also there. Right, you can write in as many as the numbers. And 200, for 200 also you can write 1, 2, 4, 5, 10, 20, right, 25, 50, and 40 also there, 40, 50, 100 also there. So you can write these all the different types of divisors. But all these divisors, these are all, you can say the divisors of these numbers, but we need to do what? We need to take the common divisors. So common divisors of 100 comma 200. Common divisors of 100 comma 200 is what? So 1, 2, 4, 5, 10, 20, 25, 50. Right. So these are all the common divisors. Common divisors for both G's 100 comma 200. So but what we need to do? We need to take one greatest common divisor. We need to take greatest common divisor. So greatest one is what? Among these all the numbers, 50 is the greatest one, right? So 50 is the greatest one. So you can write 50 is the greatest common divisor. Greatest common divisor of 100 comma 200. Like the way you can write, or else you can write like this also. GCD of 100 comma 200 equals to 50. This is the way also you can write. Right. So this is the topic we discussed today. So I hope all of you understood. So finding the GCD is simple way, but we need to choose the common divisors and we need to find the greatest common divisor is somewhat difficult, right? So that is a difficult task. So you can do it, practices. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.